How was the first session? Awesome, good to hear. So my name is Fluin. I'm a developer advocate at Google. I work on the Angular core team. My role is really to to do two things. First is to listen and understand kind of what's going on in the community. And then second, I'm really here to help businesses and individuals and developers be successful in terms of using Angular. So for most of my career, I actually was in software consulting. So I would go out to companies and I would help businesses make decisions about how to use technology. So a lot of that stuff about the pendulum and whatnot this morning really resonated because those are really hard choices, right? And there's an element of fashion to it. There's an element of science to it. And understanding all of those nuances can be very tough. And so I spent a ton of time doing that. But I ended up at the Angular team because I really kind of believe in their mission, what they're trying to do. Apparently I need power. Let me just fix that one second. All right, quick commercial interruption. Now it should be better. As I was saying, I really like what the Angular team is doing. I like the team. So I only joined probably about 7 months ago. And so I've been on this kind of wild ride for about 7 months, and I'm really excited. But at the heart of it, Angular is about existing to make building applications on the web easy. And so there's a lot of different definitions out there for what we mean by building, web, and easy. And I'm going to get into a few of those in terms of what I mean by those things as we go on here. This is actually a really great day to be talking to you guys because 2 days ago we announced Angular 2 Final, which, yeah. So that release was a little while coming, but we're very glad and we were very happy to have a special event a couple days ago. How many people here were able to watch the live stream or see it in person? Okay, a few people. So what that basically meant is that we've been in the development mode for a long time. First we did alphas, then we did betas, then we had a few RCs. And now that we're at Angular 2, we're actually doing a few things different. We're switching to semantic versioning. And then we're also kind of making more of a promise around stability. So we feel really good about Angular 2, and we think everyone is going to continue to love it and try it. So I'm going to do this talk in kind of 3 sections. First, I want to reflect on the modern web, so kind of where we are as an ecosystem and as a technology society. I'm going to talk a little bit about getting started, and then I'm going to talk about Angular as more of a platform. So just in terms of background, how many people here have built an Angular application 1 or 2? Awesome, thank you so much. And now of those people, how many people have built an Angular 2 application already? Great. So thank you guys so much for coming in to an introductory talk. And I think the rest of you will hopefully have a fair amount to learn. And hopefully I can help you guys on your journey. So to get started, I want to talk about the modern web. Because for me, I really feel like frameworks of any kind are created as a reaction to the technology at the time of their creation, right? So thinking of the pendulum, you're kind of sick of all these problems that you have with a library. And so you say, I need a better thing. I need a framework to go and solve that. And so to understand some of where Angular is coming from, I think it's important to acknowledge several parts of the modern web ecosystem. First and foremost, the web is everywhere now. So a long time ago, we only had desktops and laptops, but now we have mobile devices. And those mobile devices are basically everywhere, all over the globe. I mean, if you look at some of the emerging economies in the world, they almost exclusively use mobile devices. And it's not just apps too, right? So if you're launching a business in 2016, you cannot just have an app or just have a website. You kind of need to understand both of these things. And the web is different there, right? So on desktops, we have very powerful CPUs. We have very powerful GPUs. But on mobile devices, that's much more constrained, and we have a much smaller battery. And so understanding how you build applications in order to take advantage of that and to take care of that is very important. The other piece that's happening with the web being everywhere is that we're seeing the web run in different places. So how many people here have heard of Electron? So Electron is a framework that actually allows you to build applications for the desktop using web technologies. So you actually get basically a browser and an instance of Node running on any computer that you can control and then give those desktop-like experiences. Another thing that's happening in terms of the modern web is experience, and speed is one of the foremost parts of any sort of web experience. Because the reason that the web has become so popular is because when you run something on the client side, I'm not going to stare at a blank screen for a second while that page is flipping, right? And so the speed of that was a huge win, and we have a lot further to go. And so there's actually a performance concept called Rail, which looks at several various parts of the performance story. The first is responsiveness. So after a user interacts with the screen, how long until you actually take care of that action and do what the user's trying to do? You've got animation. How do we generate smooth and fluid animation? So anything that you're doing from a processing standpoint, you have to return that next frame within 16 milliseconds. Idle. How do we maximize idle time? Going back to the idea of that more and more applications are on mobile. We actually need to maximize the amount of time that your application is not doing anything, and have that as a goal. And then lastly, load time. So how long does it take not only for your page to load, or the initial DOM to load, but what's that time to first user interactivity? It's a very important concept. Another thing that's happening in the web is, as if any of you attended the TypeScript talk earlier, the web is changing, right? There are new standards that are better ways of building applications because we're kind of relearning from the past, right? We're relearning from what happened in the kind of C world when we started building desktop applications tens of years ago. So now in JavaScript, we have classes, we have modules, we have decorators, and then there's even things like web components that allow you to kind of more finely encapsulate HTML. And then you've also got this shift to observables and reactive programming. I'm a huge fan of observables, and we'll talk about them in a little bit. The next thing that we need to acknowledge on the web is that more and more of the web is not running in the browser. There's this idea that Node has made really very popular, among others, that we can actually run JavaScript and use the same language that the client's running, but run it on the server. And so single-page applications are fantastic, but maybe we can actually augment them and run more of our JavaScript on the server in kind of similar ways to have better connections there. The last piece I want to acknowledge in terms of the modern web is really just, it's an ecosystem, right? None of us here are writing JavaScript alone. We're writing JavaScript kind of on the shoulders of giants. And on the left here, you actually have a huge list of dev dependencies for the Angular framework itself. And so that's actually a really good thing, right? So if you're building Angular, you want to be taking advantage of all those things that other people have been built. And then the top section there, that's the actual dependencies. So right now we only have 4 dependencies to use Angular, which is pretty good. But then I've also on the right side got NPM, because you, as I said, you're not writing JavaScript alone. You're writing JavaScript alongside thousands and thousands and thousands of other packages and programs that you're going to be dependent on, as some as dev dependencies, some as build and runtime dependencies. But then there's also some great things like Webpack. Right? So as the applications that we're building continue to scale, they continue to get more complex, we need better ways of shipping those applications to users. And so Webpack is one example of a way that we can take this idea of building an application using web technologies and then deliver it in kind of nicer ways to the client browser. And then the last piece there, that's the icon for Protractor, which is actually an end-to-end testing tool built for Angular. So Angular 2 was really built with and for the modern web. So we want to acknowledge and understand all of these things are part of why we built Angular 2 and how we think about those things. So I'm going to get a little bit into getting started. There are a lot of people in the crowd that have done Angular 1. So I'm going to do a little bit of a brief crossover for you guys. If you think about Angular 1, it actually has the same philosophies as Angular 2, right? So you've got things like declarative templates with binding. You've got if you're following along with the kind of Angular 1 recommendations, you still have that same component tree. The one big thing that's happened is we actually have fewer Angular parts. So Angular itself is actually much simpler in 2. And what we're doing is we're relying more and more on some of those modern web standards. And so an example of where you'll see that is throughout a lot of Angular sample code or any code bases you build, you're probably going to be using ES 2015 modules to be loading in different parts of your application, to be splitting up your application. And so that's a very standard thing where before you would kind of do it the Angular way. And then we've also built tools like ng-upgrade. And so ng-upgrade is a tool that allows you to basically bootstrap both the Angular 1 and the Angular 2 runtimes, and then you can import components from one to the other. So if you want to do kind of a more softer upgrade path, you can actually start by building some Angular 2 components and then import them into your Angular 1 application, or vice versa. So the session immediately prior to mine talked a lot about TypeScript. So Angular, you can build Angular applications using TypeScript, ES6, ES5. They kind of all work. The Angular source code itself is written in TypeScript. And just so you understand some of that, TypeScript is really just JavaScript plus types. But when you look at this chart, the thing that this is trying to illustrate is that it's kind of the best of JavaScript. So the ECMAScript standard made by TC39 is really focused on how do we figure out what people are using, what people need, and how do we standardize on those things. And so TypeScript allows you to take advantage of some of those things without having to worry about backward compatibility or without having to worry about browser compatibility. I know about 3 years ago, I never would have thought that I wouldn't have to worry about browser compatibility, but we've almost gotten to a point with the evergreen browsers where you don't have to worry about it, right? With things like transpilation, you can write JavaScript in the way you want to, and it's going to run everywhere, which is really a fantastic world to live in that I never could have hoped for. So one of the kind of core concepts in Angular that you're going to see is modules and component trees. So if you look back at Angular 1, everything was a little bit more fluid, right? You had a $ scope that you had that was attached to a controller sometimes if you weren't using a component-based architecture. And you weren't exactly sure where things were coming from. And neither was Angular. So we had this thing called the digest loop, right? So we basically ran all of the expressions in your template and said, hey, did anything change? Are we done? Maybe we'll run it a couple more times until things stop changing. And actually with Angular 2, we've completely redone that. When we do change detection, when we evaluate any of your expressions or we're trying to evaluate any of our bindings, we're actually doing it as a directed graph using this component tree. So you've got module A and module B here, and then you've got components within that. And so let me dive into what a module looks like. So this is a very simple module. You're going to use decorators, so it's one of those more modern ECMAScript standard things, to actually add metadata to just kind of basic ES5 classes. So we've got declarations here, which basically says, hey, what components are going to belong to this module? You've got imports, so you can actually pull in any third-party libraries, and they can do a lot of things. They can say, hey, here are all the components I want to offer within your application. They can do things like apply providers. So in case they need a service or they want to set up a service so that whenever your application is accessing that service, it has to be the right singleton. And then you've got things like, then you've got the bootstrap, which actually is the thing that connects the HTML that you've written to the ng module that you've built. So then you'll see the reference here to app component. So underneath the level of modules, which were an Angular 1 concept as well, we have components. And so a component is really just a directive with a template. And so we'll see kind of two things on this component. We see a template URL, which is going to be a relatively basic HTML template. And then we're going to see a selector, which again tells us what HTML tag we want to bind onto. So then one of the core parts of the component here is that template URL. So in Angular 1, we had a ton of directives. I think there were more than 50 directives. We've tried to simplify things a lot. And so you're going to see basically these three things in most cases. So you're going to see string interpolation. So if you use the double curly brackets, you're able to say, hey, use this variable. You're able to do attribute binding. So any HTML attribute from either the kind of stock standard HTML or from your custom components, you can bind into them with this syntax. And then lastly, you can do event binding. So anything that emits an event. So if it's a button and there's a click event, you can listen for that. And so let's look at what that actually looks like on a sample template here. So you can see we've got an H2. So I've got profile for curly brackets person.name. So this should be very familiar if you've ever written Angular 1 or any templating language. And then the second is an image here where I've got source. So I'm actually binding to the source, and I'm binding the URL that's on that model. And then next I've got maybe a badges leaderboard, which is another component that I've built in my application, and I'm binding to its attributes. And then lastly, maybe there's a congratulate button that lets me click on it, and then that actually passes into my controller, my component, a congratulate method. The last kind of pillar that I think of when I think of Angular 2 is services. So the nice thing about Angular 2 is that services are really pure ES 2015 classes, right? These are just very simple objects. And so this is a very simple one. So I've exported class counter service. I've set up a private counter. And then I've got a constructor that creates that counter and initializes it at 0. And then every time I increment that, I'm going to return and increment that value. So this service then gets provided at any level in your application. And then you can be assured via dependency injection that that's going to be a singleton. So if I provide this service at my root app component, then throughout my application, I'm going to see the same counter counting up. And I won't have kind of multiple instances running around unless I wanted them. So the last section here that I want to talk through is that Angular as a framework is fantastic, but we really are starting to think of Angular more as a platform because there's actually a lot of different things that we're doing to improve the developer experience. So here's a big long list. So we've got everything from PWA, which stands for Progressive Web Applications, which allows you to do things like offline applications, native applications with things like native script, so you can actually build native mobile applications with native UX using Angular, to things like running an Electron on desktop and so on. But I want to call out kind of my 5 favorite parts of Angular as a platform. The first one is the Angular CLI. So and we've got Hans here in the front row who's actually giving a talk later on the CLI. We've really tried to make it as easy as possible to automate all of the parts of a developer workflow. And so there's something like 7 or 8 steps that starts with how do I get started? How do I scaffold a project and start using the right tools? All the way to how do I test it? How do I build it in the right way? All the way to how do I build it, publish it, and serve it in kind of nice ways. And the Angular CLI is really designed to help you automate each and every part of that. And so getting started with the CLI is relatively easy. After you've installed it from npm, you can run npm or ng init, which creates that project. So you see that over on the right. It's going and creating all of that scaffolding, all of those files. And then immediately you'll be able to ng serve, which actually serves out those files. So we talked about this a little bit. So you can scaffold projects. So not just the initial build. You can actually build new components that way. You can build, again, you can structure your application with the CLI. The CLI will actually configure your bundler for you. So the latest version of the CLI uses Webpack. And it will actually do all of the configuration for you. In the default build, or actually in the standard build, you won't see a Webpack configuration because the Angular CLI is actually looking into your app and saying, OK, how should I be configuring it so that this Angular application works great? It'll do things like SCSS compilation. It will run both end-to-end tests as well as unit tests if you have Karma or any other unit testing system. It uses kind of Webpack's development environment for live reload. And the last one is actually one of the most interesting things that a lot of developers I talk to haven't thought about, which is what I'm calling the idea of code splitting. Code splitting is kind of the corollary to lazy loading. So lazy loading is when you build an application, a client-side application, but we're not actually going to load all of the code that you're going to need. So we're actually going to wait. So here's an example application. This is a set of routes for an application. You've got things like your home, you've got the blog page, the bio page, the projects page, the speaking page. And then at the bottom, you see this admin. And so what that's actually doing is it's the routing system is instructed, hey, only when someone requests something on this route do I want to go and load the children from that route. And so what's nice about that, and the way that the Angular CLI is actually a little bit magical, is it will see this routing, and it will actually automatically split your code based on that routing. So it will build one bundle, one JavaScript file that you serve to the browser for most of your application, for all of the kind of direct, eagerly loaded parts of your application. And then any dependencies, any other parts that you've put into that kind of submodule, it will wait to load until the user has navigated there. And that's actually kind of a very magical thing that I think a lot of developers, as they start thinking about lazy loading and how to do it themselves, if you can just have the tools do that for you, that's a huge boost to productivity. Data is a really strong suit in terms of what Angular is taking care of. So I've got 3 examples of data here. So the first is GraphQL. So anyone who was watching the GitHub announcements from the past couple days, they actually just announced all GitHub data is going to be experimentally available via GraphQL. And GraphQL via things like Apollo are kind of amazing, where you can declaratively say, this is the data that I need, this is what it looks like, this is the shape of it, even if that data is going to come from multiple sources on the back end. And so you have an Apollo server that ends up routing those to multiple RESTful services or multiple different database engines. And then you just declaratively in your application say, this is the data I need. Apollo aggregates those queries, sends up one request, gets back the data it needs. Firebase is real time, which I'll give an example of. And we also support just via kind of HTTP standard JSON and REST. So in terms of data, there was a magic moment for me in terms of the combination of real-time data, observables, and stream processing. So this is a site that I was working on, a community site, where at the top you'll see my name, Steven. You'll see an admin toolbar option. You'll see this all developers, and you'll see edit buttons all over the place, right? I only see those things because I'm an admin. And as a developer throughout my career, I've written is admin if checks hundreds and hundreds of times, right? You just kind of get sick of it. And then the problem is, if the state changes, how do you reapply those in all of the right places? But with stream mapping, I can actually take the auth information of a user from Firebase as a stream, and anytime a new value gets emitted, I can map that into a Boolean of, is this an admin or is it not an admin? And then by binding to those things in my template, the second I log out, all of those buttons disappear, and the UI automatically reacts to everything I'm doing, which is a fantastic way to build applications and much more pleasant than writing is_admin hundreds of times. The last thing I think here is ahead-of-time compilation. So any sort of templating system that you're going to use to build applications requires a compiler. And with Angular, we've designed it so that you can actually compile your templates ahead of time. And we take all of that HTML and we actually turn it into VM-optimized JavaScript. And so if you look at Angular, the framework as a size of your bundle, the compiler is actually about 60% of it. And so if you can ahead of time compile, we can actually save that entire 60% and really just ship the parts of your application that you care about. Last piece here is maintainability. So there's actually a bunch of tools that really make Angular applications more maintainable. So the symbol on the left is Augury, which is a real-time browser extension that allows you to inspect the kind of state. You can see the whole component tree visualized. There's Codalyzer, which will actually lint and help you enforce style guides. Protractor, which I talked about, as well as just TypeScript, right? When you build large teams or you have applications shared across teams or even a developer team of greater than 0, when you come back 6 months later, if you can help understand what's going on with your code, that is a fantastic thing. So I talked a lot about the modern web, but I do want to just leave you guys with a vision of kind of the future. Because I really believe that every web application in the future should be ahead of time compiled. You shouldn't be shipping kind of raw HTML. You should be shipping something that's really friendly for a VM. It should be server rendered, so you don't have that extra time to boot up on a mobile device, for example. It should be a progressive web app. It should work offline. It should run in a web worker. So we have threading now in JavaScript, but most people aren't able to take advantage of it. In Angular, you can actually say, run my Angular application in the web worker, and then just propagate back DOM changes, which is really exciting once you see that working. Applications should be lazy loaded, so we're not running and loading code that we're not going to run. Internationalized, right? Because most of your users are not going to live in the same country. And then lastly is accessible, right? If you building applications is all about increasing your audience and how do you have greater reach. And if you can reach out to people who have accessibility needs, that is a fantastic thing as well. So the action I would ask you guys to do, if you haven't checked out Angular 2 yet, definitely I would go to angular.io. We have a lot of quick starts. We have tutorials, as well as full API docs if that's more your style. Thank you guys so much.